My name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject microcontroller for embedded system having code KEC 061, what we have covered so far. We have completed unit number first, and before two lectures we have started with the unit number 2, and in the unit number 2 it is all about the MSP 430 microcontroller. And in previous lecture we have finished the detailed description of the detailed block diagram architecture of MSP 430. We have seen its features, what are the functions of our different blocks of MSP 430, what are the important functions of MSP 430. After that we have seen that the pin description of MSP 430, what are the various pin values in case of MSP 430. We have completed the memory layout architecture of MSP 430, what are the different memories range of in MSP 430. After that we have seen the pull up and pull down concept in MSP 430. We have completed the register organization of MSP 430. So, in this lecture we will start with the instruction set and instruction formats in MSP 430. So, in today's lecture we will cover the what are the different instructions available in MSP 430 to execute our programming. Okay. So, these are the table of contents in MSP 430. Just a second, I am taking the marker. So, these are the table of contents available in MSP 430 microcontroller. First, we will cover the instruction set of MSP 430. In MSP 430 microcontroller, what are the different types of instructions available. After that, we will see the categorization of instruction set in MSP 430. There are a lot of instructions available. We will cover through some categorization. Okay, we will see the categorization of MSP 430 under this topic. After that, we will see the examples of MSP 430 microcontroller, examples of instructions, how to execute the instruction in MSP 430. So, let us start with the first topic of MSP instruction set of MSP 430. So, before going into the depth into this topic instruction set, we will see what is the meaning of the instruction. You can see that instruction basically a command to the processor. Processor or controller will do whatever the instructions we are providing to the processor. Okay. So, basically instruction is a set of command. We can say that instruction is a set of command which tell the microprocessor that what have to do with the instruction. Okay. Whatever do with the given data. If we are providing any data to the microcontroller, so instruction will tell that to perform a particular set of actions with that particular data. Okay, to that particular data. So, we can say that it is basically a binary pattern. It is a binary pattern which is designed inside the processor. In every processor there is some binary pattern designed to perform a specific functions. Okay. The entire group of instructions, whatever the instructions available in microcontroller, for any microcontroller instruction may vary. It may be a 250, it may be a 200, it may be a 51, it may be a 150. So, instruction types of instructions may vary in a particular microcontroller. So, we can say that the entire group of instructions in any processor sports is called instruction set. So, basically instruction set represents the entire group of instructions which is available in the particular set, that means the instruction set. So, that is it is basically a collection of instructions. It is a collection of instructions all. So, instruction set represents that it has a stack which is all the instructions are available under the instruction set. Okay. Instructions written in a program tell the microcontroller which operation has to be carried out. We have seen that instructions basically represent the type of actions to do on the data. Okay. So, MSP 430 instruction set. Now, come to the types of instructions. So, we can see that in MSP 430 there are total 51 instructions available, total 51. Okay. So, 51 is further categorized into two, 27 and 24. Total 27 plus 24, how much? 51. Okay. So, in MSP 430, 27 instructions are available as a main instruction. So, the core instruction, we can say the core instructions, main instructions, the action will be performed through these instructions. And 24 emulated instructions. Emulated means the support instructions, which is a part of the instructions, the instruction which is manipulated in a main instructions. Okay. So, in MSP 430 there is total 51 instructions available, we will see that. The core instructions have unique opcodes decoded by the CPU. Core instructions means the main instruction which is available in the MSP 430 microcontroller, and other set is emulative instructions. Emulative instructions basically the manipulative instruction, we can say the instructions which is used to support the main instructions, core instructions, and that make code easier to read and write. What is the use of emulative instructions? Which is makes the code easier to read and write, but to do not have opcodes. In emulative instruction do not have opcode. We will see what is the difference between opcode and opcode for detailed explanation of this. Instead they are replaced automatically by the assembler with an equivalent core instruction. So, there is no code or performance penalty for using emulative instruction. We are using emulative instructions, there is no code or performance penalty for using that. So, basically before going to depth we will see there are two main things available in instructions. First one is the opcode and operand other than the values. Let us take here, I am taking again. There are two things available in instruction. In instruction there are two things, opcode and operands. In any instruction there is only one opcode, there is single opcode, and operands may be 2, 1, or there are some instruction there is no operand available. So, generally we are taking two, source operand and a destination operand. For example, I am taking MOV R4, R5. Okay, I am taking this. So, in this instruction move is opcode, operational codes. Operational codes means that the commands given to the microcontrollers through operational codes, through some say it is a mnemonics. So, operational codes tell the microcontroller that what is the do with the instructions, what to do with the particular data values, which tells the microcontroller that what to do with the instructions. Okay. And to whom it do, it works, will do on the operands. So, operand basically there are two types of operand, source operand and a destination operand. So, in this example R4 is the source operand and R5 is the destination operand. So, in this instruction MOV R4, R5 means that we are moving the values from the source operand, source operand R4, the values of R4 will be moved into the R5. So, this is MOV is the opcode and R4, R5 is the operand, two operands. Okay. So, this will help to clear understanding of the instruction set of MSP 430. So, this is the emulated ones need assembler and compiler to generate their mnemonics. So, basically there are three formats in our MSP 430 microcontroller, three formats of instructions. First one is the double operand. Double operand means that two operands available. We have seen that MOV R4, R5. So, this is the type of a double operand, two operands available, source and destination in particular format of a instruction. Single operand means that there is only one operand available either as a source or either as a destination, only one operand will be available as the name implies. Third category is the program flow control, that is a jump instructions. Program flow control means that to control the execution of the program flow control instructions available, for example jump. Okay. So, all the instruction can be carried out in a byte or word. It can be carried out .w word in a word format or a byte format. So, instruction will be carried out, you can carry the instruction either is a byte 8 bits or a word 16 bits, and address instructions are accessed using the .b. So, .b represents that byte instruction can be executed, .w means that word instruction to be executed, and .it means that it has a address instructions, A means the address. So, these are the extensions available. If the extension is omitted, we delete the extension, we are not using any extension, the instruction is automatically interpreted as, by default it is interpreted as a word instruction. If there is no extension available, it means that by default it has the instructions are accessed in a word operation, it has a word operation, that is 16 bits of data at a time. Okay. So, these in basically this slide we have seen the various types of formats and the difference between the core instruction and the emulated instructions. So, this is the instruction set, all the instructions format categorization. Here you can see that there are three formats available, format 1, format 2, format 3. There is other format is also available. In addition to that, sport instruction we will see. So here you can see two types of categories. So there is a black highlighter. Basically there is two types of coloring, black and red. So basically black represents the core instructions. Here you can see that ADD, here you can see that J and JE, all these are the core instructions, and the instructions which is highlighted through a bold red highlighter, it represents the red color represents the emulated instructions. So you can see that there are total 51 instructions available in microcontroller. Out of 51 instructions, 27 is the core instruction and 24 is the emulated instruction, and total of 51 instruction. Okay. So this is the instruction distribution, and all the instruction is categorized into a basically three format. This is the additional format available to support all these formats. Format 1 means that 2 operands available. Format 2 means that only one operand is available, either as a source or destination. Format 3 plus minus 9-bit offset. Offset, basically these are used to control the execution of the program. So format 1 has a ADD dot B, add with carry, and BIC, BIS, bit, compare, DADD, MOV, subtraction with carry, logical OR operations, XOR operations, similarly OR, maybe we can say that. Format 2 has a single operand, BR, call, swap, SXT, push, pop, RRA, RRC. We will see what is the meaning of RRA, all each and every instruction in our further slides. INV, increment D, similarly DEC, DD, ADC, these are all the single operands, that is format 2 instruction. SBC, clear, DADC, RLA, RLC, test, all these are single operand instructions. And format 3 we have seen that 9-bit offset. Offset means that if we want to jump from the, for example, I am taking, let us take instruction 1005H and we want to jump into 2500H. Okay. So the flow of the program will be controlled by these instructions. The execution of the program will be controlled by this. So if we want to jump from the 1005, we will use these instructions. If we want to jump from the 1005 to the 2500H, it has some offset address as well. So this type of execution, this type of jump will be controlled through format 3. So in the later slides we will see there are two types of jump, that is a conditional and unconditional, and there are some other support instructions available, clear C, set C, other two in addition to the three formats. Return with I, no operations, EIND, disable or enable interrupt, set clear, set Z flag, clear Z flag, set carry, clear C. These are all categorization of the instruction set. Now, so there are two things in instruction. It can be accessed either as a byte or a word. So byte instructions are used to access byte data or byte peripheral, as the name implies. In a byte we can take 8 bits. Okay. And the word instructions are used to access word data or word peripherals. So instructions can be accessed either in a byte or a word. Okay. So source and destination, source is represented at SRC and destination is represented at DST. The source operand is defined as AS and S register. AS means the addressing bits. So source can be accessed either in a address bits and S registers. So addressing bits responsible for the addressing mode used for the source, and the working register used for the source. So basically S represents the working register and AS represent the addressing bits. Okay. Similarly, in the same fashion, DST is further accessed through AD. AD means addressing bits, D means the destination, and D register means we are working on the registers used for. D means the destination and S means the source. So these D register represents the working register and AD represents the addressing bits in the destination. Okay. So there is a B oblique W. B oblique W means that B means byte and W means the word. So operation can be performed in byte or a word. So for that, it 0 represents the word operation and 1 represents the byte operation. Okay. So next slide, we will see the operands. We are already seeing the various types of operand. So, total instructions available is 51. We have seen that it is further categorized into 27 core instructions and 24 the emulated instruction. In the previous slide we have seen that. So, there are 3 formats available to represent any format: format 1, format 2, format 3. We have seen that format 1 represents the double operand instructions, and format 2 represents the single operand instructions, and format 3 represents the unconditional, that is by access through the jump instructions, okay, to represent some conditions. So, the conditional jumps allow jump to address in the range of -12. So, we can see that it has a address range. If we want to jump from particular memory address to the another memory address, it has a address range of +5122 plus 5 minus 5122 plus 512, okay, minus 5122 plus 512. So, in this range we our microcontroller MSP430 can jump from particular memory address to another memory address by using jump instructions, okay. Relative to the program counter, we can see BR branch instruction. A jump which has not been taken continues the program with the ascending instruction, okay. So, there is some important points. We can see that if we will jump from the one memory address to, if we can say that we want to jump from the 0002H to 2400H, we can see that a status register will not be affected. If we jump from the particular address to another address, the status register will not be affected. There is no effect in the number of bits in the status registers. All instructions using CPU register require only one clock cycle. In a single clock cycle, all the instructions can be executed, and 1 word of code space, okay. So, double operand instructions, this is the representation of the double operand instruction. It has this is the size of the double operand instruction, vary from 0 to 15. So, from 0 to 3 it has a D working registers value for the destination operand. D means the destination. 4 or 5 is dedicated to the addressing bits responsible for the addressing mode used for the source operand. So, the for source operand the 2 bits are dedicated for that. 6 means if we want it has a value of 1 or 0. So, 1 represents the word access, 0 represents the byte access, okay. Here you can see that. 7 pin is dedicated to the AD. So, AD means that's address for a destination. AS, similarly AS represents the address for the source. So, 7 pin is dedicated to the addressing bits responsible for the addressing mode used for the destination. So, A means the, here we can say that A means the address and for the destination, okay. And from pin number 8 to 11, it is dedicated to the S register. Basically S means status registers. So, the working registers used for the source operand. So, we can say that this is the format of the double operand. It is of 16 bits, and each particular bit has some dedicated function. It represents values, and from 12 to 15 it is dedicated for the opcode, operational codes. That is, it tells the microprocessor that what to do with the instructions, okay. So, this is dedicated for the opcodes. In the same fashion, single instructions format is given here. It also has some values 0 to 15. The difference between previous and in this single operand is that for opcode there is a value available from 7 to 15. These are the registers available, and 6 is dedicated to B/W. It has a value of 1 for a word and 0 for a byte. 5 and 4 is dedicated for the AD, address destination byte, and from 0 to 1 it is dedicated for the working registers for the destination as the source as well. These are the format of the single instruction. In the same fashion, there is third category of instruction set of MSP430, third category of format, jump instructions, program flow instruction. Basically, it tells the microprocessor to how to execute a particular program, to control the execution of the program by using jump instructions. So, format is from 0 to 15, opcode is reserved from 13 to 15, opcode value, that is what to do with the microcontroller. We have seen that there is in instruction format there is 2 things, opcode and operands, okay. So, opcode means operational code, what to do with the microcontroller, what to do with the instructions on a given data. It is dedicated from the 13 to 15, 11 and 10 to 12 available for the C, okay. That is the code values, and 0 to 9 reserved for the PC offset, 10-bit PC offset. What is the meaning of the 10-bit PC offset? It means that program counter offset value, if we want to jump from the particular memory address, for example 00002 to FFAB, okay. So offset address will be calculated by using these pins. So it has a value of PC new. PC means program counter new address value. It is calculated through the program counter old values plus 2 in plus PC offset into 2. Okay. So this is the calculation. But we will not go into the much depth of this. We have only we need only the format of the instructions. So next is the instruction set categorization. There are 6 categorization of instruction in MSP 430. Movement instructions. Movement instructions mean movement of value from one register to the another registers. For example, MOV R4, R5. We are moving the value from the one operand to the another operand. Stack operations means to indicate the stack. There are 2 operations possible, push and pop. We will see in a later stage. Arithmetic and logical instruction. Arithmetic means addition, subtraction, multiplication, division. Logical means by using which has logical operations, XOR, NOR, NOT, etc. Byte manipulation means if we are we need to manipulate the byte. Okay, manipulate the byte. For example, in a 16-bit instruction, there are higher up byte and a lower byte. If we want to swap the higher byte and the lower byte, the swapping will be take place through in a byte manipulation. Similarly, shift and rotate instruction, in a later stage we will discuss the what is the difference between a shift and rotate, flow of control instruction. So there are 6 instruction categorization. It is not possible to learn on the instructions. We will only look through its instruction set categorization. So let us start with the first categorization, movement instruction. As the name implies, we are moving something. We are moving the value from the one register to the another register, one operand to the another operand. So there is only it will be carried out only through one instruction, that is move. So move instruction can be executed only through a single representation, that is move. Move means we are moving the value. For example, move.w. .w means word access. We are moving the contents from the source. On the left of the comma there is a source operand, and from the right side there is a destination. So it means that we are moving the contents from the source destination, source to operand to the destination operand. .w means word access. Another category is the stack operations. In a memory there are stacks, top of the stack and bottom of the stack. We in a previous lecture we have seen that there are 2 operation operand possible. Push, we are pushing the contents into the microcontroller at the bottom, and we are retrieving the contents from the top of the stack. So there are 2 operations for that: push.w, pop.w. .w means pushing onto the stack, that is the source, it becomes source, and pop means we are getting the data as it works as a destination. Okay. Other categories, arithmetic and logical operations available. So it is available in the 2 operands. Add.w, add source with the destination. Here we can see that so final result will be source plus destination. Other categories is add c.w. C means the carry. The final result will be source plus destination plus carry. It will move into finally into destination. adc.w destination, add with carry. Okay, subtract with carry. So we can say that after execution of this instruction, the result will be src minus dst. We are subtracting. Similarly, we are subtracting with borrow. So src minus dst minus borrow. Borrow will be generated. sbc.w, subtract borrow bit. Similarly, compare set flags. We are comparing to 2 values. So what is the difference between the compare and the subtract? It is equal to, we are compare something. This is it as a function of subtract. We are comparing, that means that we are setting the flags only, but in case of subtract it is not possible. So there is another category, arithmetic logical instruction with one operand. There is only one operand available. We can see that clear.w destination either as a source. So there is only one operand available. Clear.w means clear decrement. .w means we are decrementing the value. It is double decrement. So we can say that we are clear the destination. Here we are clearing the destination. DST 0. 0 represents the clear. It means that we are decrementing double decrement. It has a decrementing the value. For example, it represents the destination is decremented by only one value. Okay. So double decrement means that DST will be decremented by 2. Okay. Decimal arithmetic available. There are two decimal arithmetic, DADC, .W, DADD. So DADC means decimal add carry bit, and DADD decimal add with carry. Instruction, other category with the logical instruction. Logical means to carry out the logical operations, and XOR, bit, BIS, etc. So it has a two operands, and .W SRC destination. We are logically shifting the values. XOR .W bitwise exclusive or bitwise test for testing the conditions. Bit set, bit clear. So in a similar fashion, logical instruction with one operands available. Only one operands are there. So it has, we are inverting the value. There is only one operand available, DST. Okay. So byte manipulation instruction. Byte manipulation means that the instruction do not need suffix because the size of the operand is fixed. So for example, in a byte there are higher byte and lower byte. If we want to swap the value from the higher byte and the lower byte, its size should be same, and it will be carried out through byte manipulation. For that we are using SWPB SRC, SXT XRC. So swap upper and lower bytes, word only in a word possible, only 16 bits possible, extend sign of lower byte. So we are using the instruction SWPB. So there is set of immediate instruction to set or clear the 4 lowest bits in the status register, and these can be masked using the constant registers. Okay. So byte manipulation instructions are clear carry bit, clear negative bit, clear 0 bit, set carry bit, set negative bit, set 0 bit, disable. These are used to disable or enable interrupt. So another category is the shift and rotate instruction. What is the meaning of shift and rotate? What is the difference between shift and rotate? In a shift we are shifting the values from one bit to the another, but in rotate instruction we are in addition to the shifting we are shifting in a periodic fashion. So there are three types of shift: logical shift, arithmetic, rotation. So here this is the logical shift. In the left shift it is again distributed into the left shift and the right shift. Here you can see that in a left shift we are shifting the value one by one from this MSB to this into this into this, and say that LSB is replaced by 0 because LSB is empty when it transferring its value to the next adjacent bit. In a similarly right shift we are transferring the value bitwise bit. We are transferring the value bit by bit, and in a, we can say that MSB will be empty and it will be replaced by 0. In an arithmetic shift we can see that we are shifting the value, okay, one by one. But in case of there is some difference. In case of arithmetic right shift we are shifting the value. The MSB will be repeated again. This arrow means that MSB will repeat its value same. Other bits are shifting. Similarly, rotate, we are rotating the value. We are rotating this in this periodic fashion. Node and this is rotation left, and this is rotation right. Okay. So this is shift and rotate instruction. And the last one is the we will see some more detailed explanation. Logical shift, insert 0 for both right and left. We have seen that. Arithmetic shift, insert 0 for left shift. But now MSB, which carries the sign, is replicated for the right shift. Here we can see that replicated for the right shift. Same value will be repeated. And rotation does not introduce or lose any bits. If we are rotating something, there will no effect on the bits. We will not lose any bits that are moved out of one end of the register or passed around the other. So it will be carried out to RRA, rotate, logical, rotate right, rotate left through carry. Okay. So last one is the flow of control instruction. It means that if we want to control our program execution, it will be done through flow of control instructions. It will be carried out through jump instructions. So for that BR SRC branch go to, we are going to from one memory location. For example, if this is 003, we want to move our value to FFFA. So all will be carried out through flow of instructions. So here it is called subroutines. Subroutines are the basically small programs which will be called in a main program whenever needed. So it will be called by using call SRC, return from subroutine. We want to return from the subroutine, we will use this, return from interrupt, and no operation, consume single cycle. So basically jump instructions are available: JC level, jump if carry set, jump if carry not set, jump if negative, JZ means jump if 0, jump if not 0, jump if greater or equal, jump less than. So these are basically conditional jump instruction. If particular condition is met, then jump execution will be carried out. Thank you everyone for your patience. I hope you have enjoyed my lecture. In further slide we will see the further explanation of MSP 430 microcontroller. Have a great